This video is part of a series of short videos that each highlight a different strategy that can be used when verifying trig identities and an example of how it is used. This video highlights the strategy of simplifying a more complicated expression on the left into a simpler expression on the right using a Pythagorean identity. This is going to be a good strategy to use when the left side contains two terms that are related by a Pythagorean identity. And remember, those terms have to be squared because the Pythagorean identities only include squared terms. Even the ones are technically 1 squared. The three sets of terms you're looking for are some combination of sine squared, cosine squared, and 1, or a combination 2 out of the 3, tan squared, secant squared, and 1, or a combination, again, 2 out of the 3 of cotangent squared, cosecant squared, and 1. Here's an example using this strategy. We're going to verify this identity again by showing that the left side is equal to the right side, and our identity is tangent times cotangent minus cosine squared equals sine squared. So the first thing I noticed in this problem was that the left side originally contains a tangent, a cotangent, and a cosine squared, so a lot of different trig functions. So for my first step, I actually used a strategy that is highlighted in another video, which is rewriting all of those original terms in terms of sine and cosine. And as you can see, this worked out pretty well because when you take tangent and write it as sine over cosine, and then cotangent and write it as cosine over sine, that allows you to cancel the sine on the top and the bottom and the cosine on the top and the bottom, making that first term cancel into a 1. And then the cosine squared stays a minus cosine squared because that was already in terms of sine and cosine. Now that I have my 1 minus cosine squared, now it's time to think about the strategy highlighted in this video of simplifying using a Pythagorean identity. What I notice is that when I have a 1 and a cosine squared, I know that one of the Pythagorean identities, namely the original one, sine squared plus cosine squared equals 1, has those two terms in it, a 1 and a minus cosine squared. So what I want to do off on the side is just check for myself to make sure that that is actually a valid manipulation of that Pythagorean identity. So what I did to start was I wrote down the original identity, sine squared plus cosine squared equals 1, and I said, well, I want the 1 and the cosine squared to be on the same side. So to put the cosine squared on the same side as the 1, I subtracted cosine squared. And that gives me that sine squared equals 1 minus cosine squared. So 1 minus cosine squared is something you get out of Pythagorean identity, and it's equal to sine squared theta. Now, in my main work, I can get rid of 1 minus cosine squared and substitute in my sine squared theta, which gives me what I want and shows me that the identity is true. I do want to note that showing that side work between the green arrows of checking the Pythagorean identity, that's not something that it has to be part of your work. It's something that you might be able to do in your head. What you do want to show me is that you're using a Pythagorean identity. So I just wrote arrow, Pythagorean identity, get sine squared theta. That's totally fine. If you want to show the side work, great. If you don't, also fine. So your takeaway point from this video is always be on the lookout for manipulations of those Pythagorean identities. That can make your life a lot easier by taking a couple terms and turning them into one. Always keep this strategy in mind as you are trying to verify identities.